Hi, thanks for coming to the 2022 graduate exhibition at Penn State. My name is Kevin Rosenfield, and I'm a sixth-year PhD candidate in the anthropology department. I'm going to talk to you today about some of the preliminary results of our work on the coevolution of male and female mating strategies in non-human primates. So, mating competition is a cornerstone of Darwin's theory of natural selection, because it's only through mating that sexually reproducing organisms can pass on their genes to future generations. There's intense mating competition in some primate species, but in others, competition takes a far more passive form. Many empirical studies and lots of theoretical work have gone into trying to understand this variation. As part of my research, I investigated the evolutionary origins of one particular characteristic associated with intense mating competition, and that is exaggerated sexual swellings. Throughout the female ovarian cycle, or what we would call the menstrual cycle in humans, influenced by fluctuations in steroid hormones like estrogen and progesterone, sexual swellings grow in size, and as they do, they attract sexual attention from males. This graph depicts the growth cycle of exaggerated sexual swellings in female Barbary macaques. It shows that swelling size peaks during the fertile period, which is the time when females are most likely to become pregnant if they mate. This has led primatologists to hypothesize that sexual swellings evolved as part of a female strategy to attract high-quality mates during the fertile part of the cycle. But not all species have exaggerated sexual swellings. This image shows the lack of an exaggerated swelling in a female rhesus macaque. Several hypotheses have been advanced to explain why swellings evolved in some species but not in others, and one such hypothesis relates the evolution of sexual swellings to the intensity of male mating competition. I've already told you that mating competition is extremely intense in some species but far more passive in others. So this hypothesis suggests that if male mating competition is intense, then females should evolve sexual swellings in order to attract the most dominant males, because those males have proven their fitness by beating out their competitors. In more passive species, on the other hand, females may not benefit from attracting dominant males, since those males do not need to engage in intense competition to become dominant, and so swellings will not evolve. My colleagues and I are in the process of testing this hypothesis using evolutionary modeling. We use the programming language Python to develop a model that simulates mating competition and the evolution of sexual swellings. And specifically, we predict that when we set our model to simulate intense mating competition, sexual swellings will emerge over evolutionary time, and variation in their size will mirror changes in female fertility across the cycle. And this graph shows a simplified picture of how female fertility varies across the cycle. For 10 after day 15, conception probability is 0 in this graph, meaning that females will not become pregnant if they mate on those days. Around our simulated days 12 and 13, however, conception probability peaks, and females mating on those days have a high likelihood of becoming pregnant. So keeping this graph of conception probability on the upper left part of the screen, I'll show you in real time what happens when we test our prediction using our simulation. So we're looking for the shape made by the blue dots to be similar between the simulation view and the image on the top left of the screen. The dots are average swelling size across females for each day of the cycle, and the red lines are standard error bars. The arrows indicate the fertile part of the cycle, the red arrows above and below the video. So over time, you can see that the swelling function does in fact take the shape of the conception probability function, and that is because in this model run, we set mating competition to very intense. And I'll just speed this up a little bit and skip around. And you can see that as I advance this and we get closer to the end of the simulation, which is 10,000 simulated generations, we have more and more of a similarity between the shape of the sexual swelling function over in the middle of the screen and the conception probability function on the top left. Finally, I just want to show you what happens when we set mating intensity relatively low instead of relatively high. So I'll go through this one rather quickly. You can see that while there are some random variations in swelling size making their way into the population, variability remains very high, and the pattern does not match the pattern for conception probability nearly as closely as in the previous model run. And even as we get to the end of the model run, we don't have a nice curve that looks like this curve here up in the upper left corner. So this is preliminary evidence in support of our prediction, but we plan to expand these models to cover a much wider range of scenarios and to test other predictions. This kind of work complements and is made possible by field studies of wild primates and cross-species comparisons that allow us to generate these sorts of hypotheses. And with that, I just want to thank you for your interest in my work, and to thank my collaborators and a few others who helped make this work possible. Thank you very much. Have a good day.